Okay, here we are. We're just going to take I and cross it off. That's what I like to do if I don't like to do problems. So.
So much fun trying to do notes and first half. Because we just saw you drop a little. Yeah.
Oh, because I didn't turn the mic on?
Yeah.
Sorry about that. Sometimes I forget.
My sister was like, do they always not have notes? You were just like, no, they should.
Yeah, so if you guys ever see me doing class and the blue light isn't on, the red light's on, that means the mic's off and then people can't hear me. But so, oh well. Sorry about that. Square root of a to the fourth, b to the seventh. Is that a perfect square? It is not. So I break it up into two parts. Is a to the fourth a perfect square? It is. Is b to the seventh? So I reduce it to b to the sixth. Then I need to put a b over here. So it becomes a squared b cubed roots of b. I would appreciate if you could really try to pay attention also to the language that we use when we read the expressions. Some people like to say this, they like to say a squared b cubed to the root of b. Nope, that would be b cubed to the root of b. That's what that would look like. We don't want that. Okay, that's a little bit more complicated. Yeah. All right, the next one. Are either of those perfect cubes? They are not. What is a perfect cube that you can extract? Good, x cubed, which means I put a x over here. Is y to the eighth a perfect cube? Is y to the seventh? Is y to the sixth? Y to the sixth is my perfect cube. Y squared over here. 8 is a perfect cube if it was a coefficient, but as an exponent, it's not. It would need to be divisible by 3. So notice as we take this cubed root, we get x y squared times the cubed root of x y squared. Wowzers.
Where did you get the XY? I remember doing it.
So the cubed root of x cubed is x.
Okay.
The cubed root of y 6 is y squared.
Yeah. However you said it.
That's a good test. All right, the last one. Is w a perfect square? No. Is b to the fourth is, you could try to simplify these each, but sometimes another option is, instead of simplifying each one and then multiplying together, maybe we just multiply everything together from the beginning. So the square root of w to the 6th, b to the 12th. Are those both perfect squares? Which will then leave you with w cubed b to the 6th. And that is the result. What I would like you to do is take about 8 minutes and start working through more of the problems on the worksheet I gave you yesterday. Some of you have gotten through a lot of the problems. Some of you have gotten through very few. The answer key is posted. I'm going to come around. I do want you to know that there are a number of problems on here that are very difficult, and you should have questions on it. If you could get them all, good for you. It must feel really good to be super smart. But for most of us, we'll need some help. Let's go. All right. Algebraic expressions. We're going to simplify algebraic expressions by performing the indicated operation. What is the operation you're asked to do here? Addition. So do you remember how we add these two expressions? Like terms. Good. 3x squared and 5x squared make? 8x squared. 2x and negative 10x? Negative 8x. Negative 5 and negative 9. Good. Okay, good. As you look to problem B, what's the operation there? Multiplying. So we multiply each term by each term. 4x times 2x is? And 4x times 7 is 28x. What do I do now?
Negative 2 times 2x.
Move along to the negative 2. Very good. I get negative 4x.
And then negative 2x.
Good. Am I done?
No, you can simplify it a bit more.
You can combine together the like terms. 8x squared plus 24x minus 14. What would you do for letter C? Distribute the 3. Good. So I'm going to distribute the 3 through, and to get negative 6x squared plus 3x minus 9er. What do you distribute for the next part? You distribute the negative as well. The subtraction sign counts as a negative. So we distribute the negative, and we get negative 16x squared. A positive 20x minus 4. Good. Now what? Combine your like terms. Negative 6x squared and negative 16x squared make? Good. Negative 22x squared. Done with my x squareds. I move along. The 3x and the 20x make? 23x. The negative 9 and the negative 4 make? Negative 13. See a problem like E, that's nice and simple, because 3x squared is 9x squared, and negative 4 squared is 16. Thank you. You can't do that, folks. What does it mean to square something? I'm an excellent liar. Thank you very much. 3x minus 4 times 3x minus 4. Please, folks, please. That's one word. That just digs at my heart if we don't get that. I multiply it out. 3x times 3x is 9x squared. 3x times negative 4 is negative 12x. Negative 12x plus 16. Notice that you can combine the middles together. 9x squared minus 24x plus 16. Okay, go ahead and do F on your own. F on your own. What's that? We'll do that when I say to. Sometimes I can't tell if people check their watches because they can't wait for class to be over, or if they're checking their watches because like, I don't want class to end. You know what I mean? It's kind of like you're watching a really good show and you're like, oh, I hope that there's 20 minutes left. But really, there's only 3. You're like, shoot.
I don't know. Anyone ever like that in school? Like, I'm not trying to be, obviously, you can start out vacation.
I went, for me, for math class, I wished it was 4 hours long. I just wanted to be at math all day.
You're crazy. I like it's like I want to do that the rest of my life. Yeah. You know, that's what he's passionate about.
Yeah, thank you. I appreciate somebody defending me a little bit. There we go. Plus 2x cubed. That's what I got. What'd you get? Did you get that? All good? Okay, let's try that. We'll end with problem D for today, and then we'll pick up tomorrow. We'll have time to get through the lesson. You guys can go ahead and then work on some of your homework tomorrow in class, get a different worksheet. I'm going to look at this problem. This looks like a very challenging problem. You all agree?
Yeah.
So let's look at an easier problem. What if I had x cubed times 2x minus 3x to the 5th? Could you do a problem like that? Yeah, you would distribute the x cubed, and what would you do to the exponents? You would add them. Again, I'm not doing this because I need help with the problem. I know how to do it. I'm trying to help you make an easier problem. So therefore, I will distribute this. And so what will I do to the exponents? I will add them. The only problem is that these aren't written as exponents. Let's write it so they are exponents. The root of x is the same as x to what power? Good. The root of x to the 5th is the same as x to what power? Good. Can everybody convince themselves that these two expressions are the same? Then we will go about our business where we'll distribute and we will add the exponents. 3. Yes.
the well, I had to get x3 and then 2x minus 3x to the fifth.
I just made up a problem that's easier so I could tell myself what to do.
How did you get 5 over 2?
So 5,
Right.
and then root means square root, means 2.
Oh, yeah.
If there was a 3 there, you put a 3. If you don't see anything, then you put a 2. I will distribute and add the exponents. What is 3 halves plus 1 half? 4 halves, which is 2. So 2x squared. Three halves plus 5 halves. 8 halves, which is 4. So I have 3x to the 4th. Are those like terms? Can I combine them together? No. So you are done. That's your expression. Good job, folks. We'll continue tomorrow with algebraic expressions and factoring, and you'll have about 20 minutes to work on your assignment class tomorrow, new assignment.